So I think we're good to get started for the workshop today. So, okay, so let me, before we get into Docker 101, so probably, Nancy, can you just give some introduction about the CNCF,
Yeah,
probably the motto that we started of the women in CNCF? So,
yeah,
probably you can talk on that one. Yeah.
definitely. Thank you, Bhavani. First of all, welcome everyone. This is our first workshop. So basically, we started this community, Women in Cloud Native, just to encourage more diversity and inclusion in the cloud native community. And I'm so amazed and excited to see the growth and that we are learning together. It's really cool. So we keep doing a lot of YouTube streams and workshops we are going to do in the upcoming months. And if you have any questions, you can always I can paste all the links, in the chat later. So we have our own Discord and Slack group where you can always get in touch. And if you want to conduct any workshops, so you can get in touch with me or Bhavani. We would love to have the next workshop with you. And I met Bhavani through the community itself. I saw her on LinkedIn. She was doing amazing talks and workshops at CNCF Hyderabad. And I just pinged her that, hey, would you be interested in this? And she said yes. So, yeah, that's why today we have Bhavani. Thank you so much for taking out time. I just want to give like quick guidelines. Like, if you have any questions, everyone, just please feel free to use the chat option, even to introduce yourself. And you can just unmute yourself as well in the middle of the workshop, or maybe you can ask the questions in the end. So that's all from my end. If you have any problem, maybe unmuting yourself, so you can just ping me either over Slack, CNCF Slack, or you can just ping here in the chat option. So yeah, let's get started. Bhavani, would you like to introduce yourself, a little bit about you?
Yeah, sure. So, hello everyone. So, today, the major agenda for us is like, to give you, 101 is fundamentals of Docker, like why we need a Docker kind of a workshop. So, I'll go through all the, understanding of Docker, and then, the basic understanding of the concepts in Docker, and a quick demo I'm going to give in this session. So before that, I mean, probably let me introduce myself. I'm a senior DevOps engineer in Zscaler, currently working there from last 1 year. So I'm also a CNCF enthusiast. So the folks who don't know what is CNCF, it's a Cloud Native Computing Foundation, which helps it's like a lot of open source projects built on cloud native. And so learning about the CNCF landscape and knowing about the technologies will help you to implement things in your organization. And also, it's a lot of content and a lot of knowledge to gather with this community, and the community is wonderful, I can say. And I also speak at conferences, so been passionate about that from last couple of years. So I just make sure that that ignites me in giving talks at conferences. And the second thing is like I love Kubernetes, and I just make sure I can talk about Kubernetes, DevOps, CNCF. And I also, if you follow me on LinkedIn or Twitter, if so you can see, I just post a lot of blogs on Kubernetes, Docker, and CNCF technologies, and the meetups, newsletters, and all those things. So I think that's all about me. So okay, so let's get started with the agenda for today. So I'm going to cover about like virtual machines and containers. So before I dive you into the container world, I just need to give you some basics on why containers and from where we started. And then gonna talk about the Docker and its benefits. And then how Docker is useful and how that can be done. And then so there are some keywords that we use in Docker. So it's images and containers. I'm going to talk about that, and I'll just talk about the architecture of the Docker, the basic Docker commands that is helpful for you to get started. And then so I'm going to talk about the Docker stories and networking concepts and a live demo. So that's all for today agenda. So let's get started. So before getting started with this, so consider the how the technology has grown over the years. So before the containers came into picture, so we have at first we used to have a physical server. Consider physical server as your laptop, and so you want to run an application, so you should have a machine, right? So you deploy your application a machine, and if you want another application, you deploy your application in another server. So it's like if you want to deploy 100 application, you need 100 machines. So which means you need some installation cost, you need some equipment cost, and you need some infrastructure related costs, maintaining it, managing it. It's a lot of tedious thing. So we started from there. So and then the next part that came out of it is like a virtual machine. So what does a virtual machines mean? So so in virtual machine, so you have a so let me show you that slide here. So what is a virtual machine means that you have the same hardware. So you have the physical server, on top of which you have virtual machines installed. So which means that consider on your laptop. So you're just sharing your infra like hardware. You're sharing your hardware, your CPU, memory, storage, and you install a virtual machine on top of it. For example, consider on a physical server, you can install multiple virtual machines, and you can install applications over there. So it's far better than having one application running in one machine, right? So that's where the VMs comes into picture. If you see this slide, so on top of a physical server we have a hypervisor, so which actually the heart of like how virtualization is enabled. And so we have multiple VMs over here, and the VMs, you deploy your applications, application related binaries and libraries. And so for each VM, it will be having an operating system. So even though you use the same hardware, so you have to install operating system on top of the virtual machine. So that's where the virtual machines comes into picture. So consider this ways. For example, even I wanted to deploy multiple applications. So I need a virtual machine. So how I get that? So I again, there is a overhead because you need to install an operating system on top of each virtual machine. So I need to reach out to another team where they set up the VM for me, booting operating system, giving that virtual box the details, and then once it comes back to me, I need to deploy my application. So how I do it is letting it, I have to install all the prerequisites. For example, if my application is Java, I need to install Java. I need to install other libraries, dependencies manually, and then set up my environment. So this is how it works with VMs. But what is containers, right? So containers is like the buzzword in recent technology. So what does mean by container is, so in virtual machine, so you consider sharing the hardware, right? But now in virtual machine, so after the hardware, the physical server VM, so you have an host operating system on top of which we have a Docker engine. So which means you're gonna share the hardware and the operating system. For example, so you have a machine, so on top of your machine, you can run thousands of containers. So using the same resources and same operating system, you don't have to. The container doesn't mean that you have to install an operating system out there. So it just shares your Docker host machine's operating system. Because you don't have to install an operating system, it's very fast. You can just spin up a container very easily, and the size of the size of the container is very less because it doesn't have an operating system inside it. It just have, consider this container is a box, where your application related information is stored, and that is your application runtime. So your application is running inside that box. So that is where the because it shares everything, it will be less in size, and it can boots up fast. So that's the difference between virtualization and containers. It's kind of it after the physical server, we have a VMs which shares the hardware. We have a containers which shares the hardware plus the operating system. So now in the real world, so it doesn't mean that whether a VM is being used or containers is being used. So what exactly it mean is that, so you're gonna combine this both of these technologies. So uh, before that, you used to deploy one application in one VM. Now we consider it like on a VM you're gonna install thousands of applications, right? So that's where the real world of technology is working now. So that's about the difference between virtualization and containers. So I hope you all got the point. So just feel free to ask me if you have any questions. Okay, so now, so Docker is a tool that enables the containerization. Before Docker, also we have containers, but it doesn't that get popular. So it gets popular after the Docker, the tool that modules that containers actually with more and more features. So, so as I said, like Docker is a tool that enables you to use containers. So let me just go through the benefits of it. So, as I said, like you can be easy. So it's just a container. So it's a package of your application. You can easily deploy your application in any environment, and so. And it can be shared between your system to another system here. For example, you have developed an application, so you just set up everything and you just containerized it. You can so you just so after container means that it gets to an image, right? So now you just share with your friend that image. In his machine you just need to have Docker installed, and he can just run pull that image and run that image inside his or her container, so it just work. So that's how it's easily shareable, and it's lightweight. As I said, it doesn't have an OS dependency, and you can have a less maintenance and everything. So that's how it work. So just let you know the real time scenario over here. So before the Docker, the containers comes into picture. So if a developer is developing an application, he just makes sure that so he or she is like just make sure install everything manually and then deploy the application code over there. But now but after this is done, if he wanted to share it with someone, so he just say, hey, here is my code, you can just use it. So now, so your friend started running that, the code in his laptop, and he said like, hey, it didn't work on my machine. So then, so it's like, for your point of view, no, it's working on my machine. So, but he said it's not working on his machine. So there is because in his machine the versions of the things are different. Probably he need to install some modules. There's a lot of extra steps. The OS dependence related versioning of a modules are different. But if you just containerize your application with the whole environment and just share that image with him, hey, this is my image, Docker image, you just use it. So you can just pull it and then it just works out, because it's the same environment, it runs the same way anywhere. So that's about Docker. Okay, so let me just tell you how can we do this. I just like, you can just share your images, right? So, so how that easy sharing enables by Docker is like, we have a Docker hub, so public Docker hub. So during the demo, I'll just show you, how everything is going to work out. But consider that you have a Docker hub as a site where your images are stored. It's a public repository, so anyone can, use the images. You see the, big application like Nginx, even the Ubuntu, Redis databases. So everyone just make sure that they containerize their application and they put it there. So if you want any application to be running, you just do a Docker run command. It's as simple as that. So here, if you see this, slide. So if you wanted to install Ansible into your system, like you want to install Redis, Node.js applications. I mean the Node.js software. You can just do run Docker run, and it's as simple as that. So now let me just go to the other thing part. So I've been using that image, containers, all these things, right? So let me give a brief idea of what all this are about. So So Docker file is where your, for example, if you want to run so after you have a base image, you want to run Python on top of it, or you want to start the container to be started with a specific command. So all these things you just give inside a Docker file as a set of commands. It's easy, I can say. It has a like argument types of fields where you just see an instruction. And so the Docker file is where you just have all the rules listed. And once you build your application using that Docker file, it becomes an image. Okay, so this image is where you share it with everyone. So you containerize it and just share it with everyone. So they just pull that image, run that image, and then it becomes a container. So those are the buzzwords in Docker. So I'll just try to give brief idea about what are those. Okay. Okay. So let me get you through the architecture of Docker. So we have so in my machine, so to get started with Docker, so you need to install Docker on top of your machine, right? So we have, you can see if you want to install Docker on Linux, it's easy. Just you can just install it. And on Mac, the best way is to use Docker desktop for Mac. On Windows, you can use a Docker desktop for Windows to install Docker. So that's Docker client environment I have. So if you use a Docker build, run, pull, so what? So you're using a Docker API server, and the Docker daemon is what that listens to the API server instructions, and it is responsible for generating those images, the containers. That's where Docker daemon comes into picture. So, and as I said, like we have a registry. So everyone can just push and pull from that registry, I mean the Docker Hub. But consider that if you're working in an organization, it's not always that secure to publish your application. So in public registries like Docker Hub, so you need to make sure that you create a private Docker registry. You can use kind of tools also provide that. For example, JFrog has the Docker content registry. So probably you can just get through those things in Docker documentation after the workshop is done. So usually how organizations do is that they have their private Docker registry where they store all their Docker images, and they use that. So they just do authenticate with that registry using a Docker login command, and then they just pull and push the images over there. So that's what the registry comes into picture. So this is the whole architecture. It's like Docker API server that you know that invokes the Docker host, and Docker daemon listens to that Docker API server, and you just create the images and containers for you. Okay, so let me start with the next things, which is like the basic Docker commands. So don't worry, probably if you're first time listening to Docker, so when I run the demo, you'll probably understand it. The end-to-end understanding you'll get. So these are the basic commands we use. For example, so you have an image, so you want to run it, so you have a Docker run command. So when you run a Docker run an image name, so it just pulls that image from Docker Hub, and it just run the image for you. So it just create a container in your local environment. And then to list the whatever the containers, so you use the Docker ps command. And so to stop a container, you use Docker stop. To remove a container, you have a Docker remove. And then we can list Docker images, okay, using the Docker images command. And so we want to remove a Docker image, use Docker RMI. And you want to pull an image, as I said, like Docker pull. And you want to exact to the, which means that you want to go inside that Docker container and run some commands. You can use Docker exact commands. So these are the basic commands that you gone through every day when you use Docker. Docker is not a rocket science. It's easy. And so I would say just learn the basics. And then so you can follow the docker.io the documentation pages to to go through and understanding of everything that you need. The next part is, so I said, right, so we have a Docker file, right? So after building that, you get an image. So I just wanted to show you a brief I can say snapshot where you can see how a Docker file looks like. So you can see in this Docker file, so we're using from Ubuntu, which means that for my container, I'm using a base image as Ubuntu. So my container is actually a Ubuntu instance, and I'm just running some commands over there. So I'm just telling the instruction to run. So update my the environment, and then install a Python. I'm installing a Python package and installing some Flask application that's showing here. So just installing the whatever the uh, I can say the uh, uh, so what I mean to say is like install whatever the packages that you need. Okay, so I'm just copying my. So the what copy does is like it's going to copy your Docker host, the code in here. So here like copy dot means in my local directory. So my the application code I'm just copying inside the container to a specific path. That's what copy does. And I'm just giving an entry point, which means that so after the container is up, this is the first command that's going to be running. So it just so when I create an image, it reads from this Docker file layer by layer. Docker follows the layered architecture, which means that just go through the instructions one by one, and it just create an image for you. So during the demo, you're gonna see like how it look like. That's all about this one. So how a Docker file looks like. Okay. So there are some other concepts. So the two important concepts in Docker, which is Docker storage and Docker networking. So let me just go inside that, go through that. So what is a Docker storage mean? So if you look at the container, so when you run a container, and once the tasks are done, so whatever that you want done, so the container is going to be exited. Okay, so if you wanted the data to be persisted, which means that it just the image layer, in the sense like if you see here, so whatever the image that you have created, the image layer, it's not like so once the container is exited, so when you run the image again, so the data won't be there again. So which means that you install an application, you added couple of entries, which means you added a data, so which gets added inside the container, but the container is exited, the data is also vanishes. So you need to have a solution where you can persist your data. It's not that when you run a container, you want to start up everything from scratch, right? So you need that data persistency. That's where the Docker storage comes into picture. So here, if you look at this one, so as I said, like the image layer is the read only. So to make it read write, so what you need to do is you can use this option -v data volume. So here, what I'm trying to do is the var lib mysql path inside my container, I'm just creating a volume inside my Docker host, so that so when running the application, I'm just mapping that the container volume to my Docker host volume, so the data will be still there on Docker host. For example, if I'm running the mysql from my machine, so my machine is actually a Docker host, so you could see the data is getting stored inside the volume, which is /data mysql folder. Okay, so if you don't give a path kind of a thing, so it gets added inside this folder. So when you install Docker, you could see this path var lib docker volumes. And if I don't give a path kind of a thing, so it gets added inside that folder. If I just give a path, so it just create that volume for me, and it just add it to that location. So we can create a volume using a Docker volume create, but if you just use this option during the Docker run, it just create on the fly for you. So you don't need to create the volume and map it here. Okay, so that's how the storage works. That's how you can persist that storage. So coming to next, so let's get like how a Docker networking works. So by default, when you run a Docker container, if you don't give any option, it uses a bridge network, which means that So consider inside a Docker host, so you have a multiple containers and that should need to talk to each other. So the bridge network act as a bridge between all these containers, and from so it just create network interfaces between one container to the bridge network, and from bridge network to the other containers. So that's how the whole networking works in Docker. So you can see in this image, like, so we have a bridge network, an IP assigned to it, and the containers, still be able to talk to each other through this bridge. So as I said, like each container uh, get assigned to an IP address. So for example, so you can use a none option. So to Docker run Ubuntu, hyphen network is equal to none, which means that, so it's an isolated container, so it can't be able to talk to other containers. It just run the same single container, so it's not exposed to even other containers in the inside the Docker host environments. It's just a single instance. It's not going to talk to anything else outside. Okay, so if you use a host network option, so what it will do is, like, so whatever the port that your application is exposed, the same port can work from the data host. For example, so inside your container, if your application is listening to port number 5000, so there's no extra thing that I have to do. I just do the IP of that container. For example, consider it like 172.17.0.2, and then give the web container port, the host port, port that is defined 5000. So it's same work. So that is not the case, if you're using a bridge network, so this is the by default and I think the recommended way of networking. So if you want your container port to be exposed to host port, you need to use the hyphen port option. So where you can say, for example, hyphen port, I want this 5000 port of my container to be mapped to 8080 on my local, I mean the Docker host. So if you just once your application is deployed, you can just be able to from the local host, that port, you can just see that application running. Probably you'll get more understanding of this when I go through the demo. Okay, so that's how a Docker networking works. Okay, so let me just go to the next slide. So now I said, like, so I have a bridge network, that's run by default. But if you want, if I want a separate network, so I don't want all of my containers wanted, talking to each other. I want, like, probably a front end containers talk to only front end, uh, you know, uh, uh, only if the front end containers and the back end containers want to talk only back end. It's not gonna vice versa, like front end talk to back end. No, I don't want that way. So then I can create a network myself using a Docker command. So you can see that on screen. So just creating a bridge network, and I'm giving the IP network range, and then so it can create the network for me. So you can use Docker create network, and using this, you can just map things over there. So that's about how Docker networking works. So just want to give a quick recap, and then just started with the demo. Okay, so just started with probably what is a virtual machines, and what is containers, and then I just started, so why Docker and its benefits, and then image containers and some basic Docker commands, and the concepts of Docker storage and networking. So let's get started with the demo. I think we still have good time. uh, okay, so okay, let me share my screen. Sorry, share this command prompt once again. So, okay. Are you all able to see this, right? Okay, so one second, I'm just trying to open this. Okay, okay. So, okay, so now, so if you look at here, so I am inside a, my application code base, where you can just look at the package. Or I have a Node.js application. It's a simple application, so I just have a source code and everything over here. So if you look at here, so I just have a Docker file here as well. So the purpose of this demo is, I'm gonna build the a Docker image from my Docker file, and I'm gonna push to the Docker Hub. And then and the next thing, I'll just just clear all my images and everything, and I'll just pull that image again and see the application up and running. Okay, so this is the complete agent of Docker, right? So I just gonna go through the steps. So before I just go to the step, probably I'll just go to the commands that I ran, that I showed you. So you can just see uh, Docker images. See, you can see this, all this. Probably let me just make the font a little big. So you can see, probably, all these images are inside my machine. It's currently running. So I'm not running. So these are the images that I pulled, and you can see probably Docker PS to see if any containers are running. No, I don't have any containers running at this moment. Probably I can just see exited containers using -A option. So no, I've deleted all the images. Okay, so but if you use -A, you can see the exited images as the exited containers. Sorry. So, and you can just do a Docker pull to pull an image. For example, let me just show you this. So Docker Hub. So as I said previously, this is the site that I've told you. It's Docker Hub. So where you're gonna find all the images. So if you want, I just gonna do some simple image. For example, I can say hello world. Yeah, so you can see this. So I'm just going through simple, but you can just install Redis, the databases and the operating system, OS, and everything. So you can do everything. You can see. So see this. There are a lot of images available. Python, the Node, and Apache and everything. So MySQL. So whatever, even the Docker. So everything is available. You can see. So just whatever the major applications that the IT enables, they just make sure they containerize their application for easy sharing for the customers, right? So before I started, so let me just go through a sample image to show you. Um, so okay, so just see, you could see, in the Docker image that is showing. So it will tell you tags as well. So see, what does a tag means? You can tag your containers as well. Probably I missed that command. So you can just use Docker tag command. For example, it's not always, you should have that versioning, right? So for your application, you have a 1.18 version or 19 version with some updates. So what this means that is that, so based on the tag, so users can be able to identify what version of the application it is, and so based on that they're going to choose. If you don't mention anything, just try to pull, so it just pulls your latest image. But that's how the tags works over here. And in the overview, you can actually see, how you can install these applications, not in this image, but if you look at other image, they just mention like how you can install, and where you can just map your the ports and everything. You can find those things as well. So let me just pull this image, just make it a little less. So I'll just run Docker. So before that, I told you, right, I have a Docker desktop running. You could see this is the Docker desktop. So I just install on my machine, so that Docker desktop will also give you Kubernetes environment. So just good for the developer testing purpose, right? So I just run Docker probably I just copy paste that command, which is docker pull hello world. So I'm just running it right now. You could see I didn't specify any tag over here, so just taking the latest and it just pulled an image, right? So you could see it got pulled that image. Now if you just so now your image got pulled. So if you just check the Docker images command, you could see this, image got listed in your images thing. So what I'll do now is like, so I have this thing. So I just run this, image to make it a container. So Docker run image, right? Simple application. So just using it. Okay, so you see, if so, the application is code is like this simple. So just tell you hello Docker. Okay, so so this message shows that your installation appears to be working correctly. So just a simple explanation how users share their application to others, right? So just build their application and show it. I mean, push inside the Docker Hub, and so you just pull it and run it, and that's it. That's simple, right? So next, so this is one scenario that I would like to show you. The other part is, let me just do this from scratch. Sorry. Sorry, clear. Okay. So I have the application code. So this is my a simple JSON, Node.js application. So what I'll do is now I'll just show you the Docker file. So what I'm trying to do here is I just take the base image as node. Probably you can just search this one from Docker Hub. So you can just find that here. So see, so there is this is what the image I'm trying to use as a base, and you could see the Alpine versions, right? So I just use that tag, similar tag to in my code base over here. So I'm just using that image. I mean, the base OS, Alpine is a Docker lightweight OS, and which has Node installed. So that's what the image that I'm using as my base OS. And then, so I'm running inside the app. So what does workdir does is like, so whatever that you copy here. So what this copy does is all my application code inside this folder gets copied to the container under this working directory, so under the app. And I'm just running yarn is basically a similar to npm, right? It's a management solution for your dependencies and all. So I'm just installing that, and I'm just running this, just specify the command and making this to export at the container level as 3000 port, right? So this is what my Docker file is. So now I just do a Docker build command, clear ls Docker file. So now I just run Docker build. I'm just giving a tag for here. Probably I'll just give say Docker 101 demo. Okay, so just giving my current folder to build it. So that's what I'm running it. You could see, my it's building the image for me right now. So you could see, so based on whatever the layers that I have mentioned, it usually shows that. But probably I've run this application before, that's where it is showing this as like, so all of them is loading from cache. The fourth one is what it is showing. But you can see all of these are already ran in a mission. That's where it just cached out. So when you run an image, after one time, if you run it again, it will show this. So it won't do all the things because it's already there. So now I have an image. So if you just do a Docker images, I could see my Docker image getting created over here. Now, what I'll do is, so as I said, I have a Docker image, but I just need to share it with someone. So I just need to push it to Docker Hub. So if you see here, so probably, so if you just look into my profile, so I don't have anything yet. So, but my user is this name. So, so when you push, just you need to make sure that your Docker image tagged with your account name, because like there's lot of people push the same kind of naming convention, right? Just make sure that so it's your account specific. Use making sure it tagged with your account name at first and then the actual image name. So I need to tag that because so I didn't tag that way when I did this. So I'll do one thing. So I just need to Docker tag. So what is the image? Docker 101 demo with so my account is like Pavani 0002, and then I just use the same thing. So now I'm just tagging it here. So if you again look at here, uh, you could see so my image got tagged with other name, right? So here, so I just didn't specify any version when I'm just building it, so just comes with the latest tag. So now I can just do a push, Docker push, and so my image, you could see that it's getting connected and it's pushing your contents to Docker Hub, right? So if you just let this completed, so just pushing it to Docker Hub to so docker.io, my user, and with this name. So far, like you build your code with the Docker file, you build your image, and you're just pushing it to Docker Hub, right? Okay, so I think it's almost done. Yep. So you could see it get pushed, and let me just open a Docker Hub and show you this with you. Uh, 1 second. Okay. So if you just refresh this, you could see my image gets right. So the image gets pushed over here, and I don't have any tags, so I just have a latest. But if you want to update this application, you just build the same code with the changes with different tag. You could see all of them gets listed over here. So that's how you push to Docker Hub. Now you post it, so you wanted to verify the pull is working fine or not, because that's where like after one developer pushes it, other developer has to pull that and able to run the same environment, right? So before this, so I just make sure that I have an image, but I didn't run in my local ad. So I didn't create a container. So let me just do a Docker run. So as I said, this port is mapped to 3000. Is it like okay? Look at here. Uh, okay, let me just list that Docker file once. Okay, that yes, it is in 3000. So I'll just do a Docker run. -d is like a detached mode, so it won't start. It won't stuck your command line. It runs in a detached mode, and I'm giving the mapping the container port to my host Docker host port, and what is the image name that I have, which is this one. Okay, so now I'm running this, since it's detached mode, it just closed out of the command. So you can access this application, just do a local host. uh, you can just do a local host 3000, and you could see my application up and running, right? So this is where you share the image, and so you just the other one just deploys it, and it gets the work the same way. So you can just add some CNCF, and some data. It's been there, but as I said, like unless you implement the Docker volume, this data is not going to be persisted because I didn't apply that -v option to have the data stored it somewhere. So if I just close this container and rerun it again, so you won't see these things getting added over here. So it looks like a fresh web page, right? So if you want that storage to be enabled, you need to use the Docker storage things to be set while running the image, right? So this is how my application. So I was able to create the image from the code, and then I was able to build it as an image, right? So I got the image ready, and I just ran it the image, and I just have container and my application up and running. So now what I'll do is I also pushed my container. So what I'll do is I'll just do delete my image, delete my container and everything, and I'll try to pull it from the Docker Hub, which where I just pushed it again, and just check the application is running the same way. Okay, so let me just do Docker images. So I'll just remove Docker. I just told you Docker RM. I just wanted to delete both. Uh, okay, so and then I deleted this one. Probably I need to delete container. Okay, Docker PS Docker RM this container ID to delete the container. Okay, so the container is running, right? So I need to stop it first. So Docker stop container ID. I just stopped it. Now again, if I run a Docker remove, it gets removed. So if I run Docker PS, you don't see any containers running. So I'm just Docker images. So I think I have to delete now Docker RMI, this one. I didn't delete it earlier. So now it's deleted. So right. So you just run a Docker images. You don't see anything related to my demo application. So and no containers running. Docker PS, no containers running. Now what I'll do is like I'll just uh, open this thing. So probably it may not work for you because you deleted it shouldn't work for you. Okay, so now this is my image that I post. So now I'll just copy this. It will instruct you how to pull this image. So I'll just do this way and just come back, and I'll just run the command docker pull. So just run it. So it downloads the image, and then you can run docker run, or else if you don't want to do two commands, you directly just do a docker run and then the image. So what it will do is it pull the image and runs it. Okay, so I'll just do a docker run. So probably I'll just show you the image right now, so you could see the image listed over here. Okay, so I'll just do a docker run. Sorry, one second. Docker run, just copy this image name. So okay, so I didn't run it on a detached mode, so it's showing this way. So I said like to run it in a detached mode, you need to do it. Let me just do one thing. I'll just stop it and run it with both mappings. Docker run -p 3000 in a detached mode. Okay, now I just open back my thing and just do a local host. Yep, so you could see the application, and you don't see the data for sure because so we didn't enable the data persistence during running the image, right, the container. So that's all. Like, so what I showed you, we have I think 8 more minutes left. So I think in this demo, what I try to show you is like build an application, build an image using a Docker file, push it to the Docker Hub, pull it from the Docker Hub, and run this application the same way. So the Docker is that simple, and it enabled, you know, a lot of things in real-time IT environment. So if you observe this, I just wanted to add few more things over here. So if you just observe through this workshop, you have a basic idea of Docker, what Docker is and how we can use it. But considering a real-time application, so you have thousands of containers running, and so if some container gets deleted or you wanted to do an upgrade of your application, so inside in all containers, there's like you should have some automated script to manage that. Just make sure that the containers are up and running every time. So this is all like a tedious task, right? So that's where the container orchestration comes into picture. So you would see the Kubernetes, what Kubernetes do is that container orchestration. It just makes sure that taking all that overhead of managing containers, orchestrating containers. And so if you wanted to deploy a version upgrade using Kubernetes, it just to make sure that it doesn't give you any downtime of your application, and do one by one, one container after other, and making sure your application is highly available. And if one of the containers got died something, and it just makes sure it spin up. And a lot of benefits of Kubernetes probably in the coming sessions. So I'll try to give another workshop on Kubernetes 101, and that will give you some idea about that. Nancy, I think just open back this one. And where is my, 1 second, I'll just open my presentation back. Okay. Okay, so I think that's all from my side today. Probably if you have any questions, you can just feel free to ask me. And if you want to know about anything, you can just ask us actually. Yeah.
That's awesome, Bhavani. Thank you so much. We have a lot of questions actually in the chat. Um, uh,
Okay, yeah.
yeah, I
Probably I
think
missed.
yeah, that's totally fine. I mean, your demo was such nice that you were in flow and it was amazing. At least the commands and everything, I also got to learn a lot. I would just request attendees, if you would like to unmute yourself and directly interact with Bhavani, just feel free to do so. Yeah, yeah. I
So
hope you're able to unmute. Yeah.
yeah, meanwhile, I'm just trying to read the questions from the chat. Containers virtualized software versus VMs virtualized hardware. So, it's not that, so what VMs do is like just make sure that you share your hardware resources. So, what containers do is it shares your hardware resources with operating system as well. And you can use a single system to spin up thousand containers, and get the your applications running with less time, and it's easy way. Okay. So there is a question. When we start a Docker engine, all the containers previously run take up a lot of space and making my laptop slower. What can be the solution for this? Okay. Um, okay. So I'm not exactly sure, but probably, um, so you want all the containers to be up and running every time. So probably I don't think, I'm trying to give you an exact solution, but if the containers are like not being used, I would say, to stop the containers, like if you're making it slow or something. But probably I'll check and get back to you, probably in person, like once after this, I think so. Yeah. Okay. So yeah, I think Tulasi has given the same answer. Like when the container is not running, it doesn't take much, resources. But you could still, if you want more, if you want the storage to be there, it still be there. But the when you don't run the uh, containers, it doesn't want to take up your RAM or CPUs, right? It should slow up a bit, but I would say just debug it further. I think so. Yeah. Okay. I think that's all about all the questions. So when will take demo for Kubernetes? I think we should ask that question to Nancy.
Yeah, I mean, we should definitely do it next time, probably like the end of June or maybe the next month. We will also have, like, I've also talked to a few more people, and they are really interested in taking Kubernetes networking workshop. And I'm also interested in learning more about Kubernetes networking. So, yeah,
Yeah,
yeah.
I think like we have a lot of folks, giving sessions and workshops through this channel. So just as you, all of you might have already joined. So whenever there is a new event comes up, I think you should be getting a mail, and we always welcome you to follow the updates from this channel that comes to your mail. And so we have a lot of other people who are going to give sessions, and just make sure to keep you updated with the CNCF ecosystem. And the other thing is, like, we want whoever would like to learn and get through CNCF. I think you can just use this go to the CNCF website, and you can just explore it. There are a lot of good projects over there. The CNCF landscape is very big, so you can just go there and check out the project. If you want to contribute to open source, you can start doing that.
Yeah, yeah, definitely. Yeah, Anushka is saying group pick. Yeah, we should definitely have the group pick. But before
I
that,
think
yeah, yes, before that, anyone in the group, would you like to ask anything about the community or maybe today's workshop or anything else? Awesome. So we have like a lot of comments that it was quite informative session, great session. I agree. Thank you so much, Bhavani. It was really great, and I think we have almost answered all the questions. Yeah, I mean, could you please share some best practices while creating Docker image? Yeah.
what is the question, Nancy? Could you please
Yeah,
share
so
some?
Tulsi asked that could you please share some best practices while creating Docker image, maybe on how to maintain a lean base images, overall size of image, and other optimizing techniques?
Yeah, I think so. If you concerned about size, there are, like, I would say, getting started with the Alpine base image. It's very less in size, and where you can host your application. It depends on the application requirement, right? So for example, if based on your application requirement, you're gonna host the base OS, but Alpine images are like very small, and I think using that will give you a lot of optimization in kind of storage or something. Yeah.
Yeah, I mean, I've also shared one page which is really awesome. I always follow that page when I'm looking for best practices. Maybe we can also have a different session for the best practices. Yeah.
Yeah. So the other question I see is like, so on the next meetup in Hyderabad, so that is through CNC of Hyderabad. I would say just follow the CNC of Hyderabad and LinkedIn or Twitter. You can just see the join to CNCF community. Then so once you get joined, when there is an event, you'll get a mail, and if you follow us, like, we just keep on posted on CNCF happenings. And yeah, I would like to see at least few people getting into the ecosystem, and learning things is gonna be amazing for us.
Totally, totally. So yeah, so before we close, do we have any other questions, Bhavani, which you would like to take?
uh, I think yeah, probably anyone can ask if you have. I don't have anything right there. So our motto is like increase more and more women into the CNCF, and we are happy to see this attendees count, and we're happy to see, we are able to inspire you to join the ecosystem. Yeah,
Yeah, definitely.
and I
Um,
would like to thank Nancy for giving me this opportunity.
yeah. I mean, I'm looking for more people who can give the workshop. I actually want to ask someone from attendees if they want to give any workshop next time. Please feel free to volunteer. Maybe now, or maybe you can reach out to me personally over Twitter or any place. Cool, cool. I think I've also pasted the links where you can follow our community to receive more updates about the next event. Yeah, that's all.
Thank you all of you for joining us today, and I hope the information is very useful for you. You've got some knowledge out of it, and keep doing your best. Yeah.
Yeah, and thank you so much for your comments. So looking forward to seeing you all in the next workshop. Thank you so much for joining, everyone. Have a nice, good time zone, and have a nice rest of the day or night wherever you have joined from.
Yeah, happy Sunday.
Thank you, Bhavani, and thank you, Nancy, for this awesome session. It was really beginner friendly, and especially that the demo part was the
Yeah,
cherry on top. So, yeah, loved it.
yeah.
And I
Thank
look forward
you.
to attend all the future events of CNCF Women in Cloud.
Hey,
Thank you
thank
so
you,
much.
Anusha. Actually, it's a lot of motivating.